So, what exactly is IMU? IMU stands for Inertial Measurement Unit. An IMU is a specific type of sensor that measures angular rate, force, and sometimes magnetic field. There are many different kinds of IMU devices, each containing various measuring tools that pertain to specific uses. For example, a 3-axis gyroscope and accelerometer would make up a 6-axis IMU, while a 9-axis IMU also contains a 3-axis magnetometer. Our ReXgen 2 data loggers have an inbuilt 6-axis IMU sensor, which can be used in autonomous vehicles for purposes such as dead reckoning, but we'll cover that a little later in this video. Accelerometers are one of the most commonly used motion sensors, and are used to measure the rate of change in an object's velocity due to linear forces acting upon it. Whether due to the force of gravity, speeding up, or slowing down, we can integrate a vehicle's acceleration to calculate velocity, and integrate velocity to calculate distance travelled. So, as you can see from accelerometer data, it is possible to calculate distance from a set start point, but in order to more accurately determine the position of a vehicle in 3D space, more data types are required. Acceleration data alone does not account for turns and non-linear movement that a vehicle makes along its journey. To solve this, most IMU devices contain a gyroscope, which measures angular velocity above 3 axes, roll about the y-axis, pitch about the x-axis, and yaw about the z-axis. Although gyroscopes have no initial frame of reference like accelerometers, when data from both is combined using sensor fusion techniques, a vehicle's position and orientation can be reliably calculated. Data from IMU sensors can be used in conjunction with GNSS-based navigation systems to allow for the use of precise tracking systems and detailed motion data to be gathered about a vehicle. Motion data can similarly be combined with sensors such as wheel speed and reverse gear signals for collision analysis and detection. Another key use of IMU is for dead reckoning calculations, where navigational data can be processed to calculate an object's position from an initial point of reference. Ships have often used similar tracking methods to those we use today, utilising compasses, last known position, and landmarks in the environment around them. Today, vehicle tracking technology is able to take on a more modern but similar approach. Cities and urban settlements are steadily becoming more and more dense with buildings and man-made structures, which, while able to accommodate the increasing populations, can cause disruptions in GPS tracking and logging positional data. When determining a vehicle's position via GNSS, at least 4 satellites must be reachable and the signals able to be received and decoded, otherwise GNSS navigation can't work. Underground tunnels, reflective skyscrapers, wide bridges, multi-level roads, and dense building structures cause significant challenges for GNSS signals to be transferred and consistent positional data of a vehicle's journey to be observed by engineers. Even with satellite-based augmentation systems, or SBAS, implemented into regions across the globe that help provide positional references for more accurate GNSS measurements, data is not always reliable or reachable. So how do IMU sensors, like the one in our ReXgen 2 IMU devices, help solve this increasingly common issue? Take a vehicle travelling through a large underground tunnel to get from one hillside to another. This is one of the many structure types that causes significant difficulty for GNSS systems and being able to locate a vehicle when these signals can't be reached. It's difficult for engineers to accurately study the vehicle's movement between these points with a GNSS signal outage. Without an IMU chip, GNSS alone is only able to estimate a linear journey between the points in which the signal was received, irrespective of the turns and variations in speed the vehicle took that could be vital to understanding the vehicle's behaviour. But with the combination of our IMU and GNSS data can be processed to reliably capture the vehicle's journey within the GNSS outage, up to centimetre accuracy. The IMU chip uses GNSS data as a reference point, and, gathering detailed motion data about the vehicle, a formula can be used to determine an exact route before GNSS signal is restored. With GNSS reaching only metre accuracy, IMU is essential in ensuring the most accurate data is logged. Using sensor fusion navigation algorithms, engineers have the ability to post-process GNSS and IMU data to produce accurate positional data at sampling rates of up to 100 Hz. When we input data collected by the ReXgen IMU into these navigation equations, values for velocity, position, and orientation can be produced, key to understanding the exact movements of a vehicle. Since IMU does not use known reference points, calculations can often contain small errors which, in time, can add up to larger errors and so on. A position estimate from the navigation equation is compared to a position estimate from GNSS when signals are received, and the difference between is also estimated. Kalman filter algorithms work by observing data over time to reduce noise and produce reliable values. Using this filter, the positional difference is input to correct the navigation equations and any positional errors that have occurred to provide a very reliable navigational solution. Our ReXgen 2 IMUs contain built-in GNSS and IMU with a U-Blocks ADR module. With gyroscope and accelerometer data having a higher update rate than GNSS, IMU solutions are able to provide a much more frequent and consistent form of data for accurate vehicle testing. Influx Technology's ReXgen 2 IMU ensures that you have a complete record of your vehicle's behaviour throughout a journey or test. The ReXgen 2 IMU is targeted at applications that require a CAN 2.0, CAN FD, and LIN flight data recorder to extreme accuracy. The device can collect vibration and positional information, even under very harsh environments where no GNSS signal is available, such as off-road vehicle logging or data collection within extreme climates, with IP65 enclosure protection. With 32GB inbuilt eMMC storage and our freely distributed software ReXdesk for calibration and analysis of your data, utilising the power of IMU has never been easier wherever you are.